In 1952, a young woman sits at a drafting table in a basement office at Columbia University. Around her are stacked columns of paper sonar readings, depth measurements, thousands of data points collected by research vessels crossing the Atlantic Ocean in systematic grid patterns. The data represent something no human being has ever had before, a reasonably comprehensive acoustic picture of what the floor of the Atlantic Ocean looks like. No one has ever seen the ocean floor. Not really. Not as a continuous landscape. The ocean is 4 kilometers deep in places, deeper than the tallest mountains on land are tall. It is cold and dark and subject to pressures that crush steel. Until the development of echo-sounding technology in the mid-20th century, the ocean floor was, for all practical purposes, invisible. Marie Tharp is making it visible. She is doing it the way all cartography is done, by taking measurements and translating them into a visual representation of space. What she is beginning to see will change the history of science. She has not been on any of the ships that collected this data. She is not permitted on research vessels. She is a woman. The theory of plate tectonics is the foundational framework of modern geology. It explains why earthquakes happen where they happen, why volcanoes exist where they exist, why the continents are shaped the way they are and positioned where they are. It is to geology what evolution is to biology, the unifying theory that makes everything else make sense. It was not accepted by the geological mainstream until the 1960s. For decades before that, the predecessor theory, continental drift, had been dismissed by most American and British geologists as speculative, unsupported, and frankly a little embarrassing. The evidence that finally made it undeniable came from a map made by a woman at a drafting table, a woman whose name did not appear on the map when it was first published. Marie Tharp was born in 1920 in Ypsilanti, Michigan, the daughter of a soil surveyor who worked for the United States Department of Agriculture. Her father's work took the family across the country, and young Marie grew up understanding maps not as abstractions, but as practical tools for understanding the physical world. She could read a topographic map the way other children read picture books. She studied English and music as an undergraduate, then added geology, a field that interested her but that, in the 1940s, offered limited opportunities for women. When the Second World War created labor shortages in scientific fields that had previously excluded women, she enrolled in a geology program at the University of Michigan, earning a master's degree in 1944. She then moved to New York and took a job as a research assistant at Columbia University's geology department, where she eventually found her way to the Lamont Geological Observatory. Morris Ewing had pioneered the use of echo sounding to map the seafloor. By the early 1950s, Lamont had accumulated an extraordinary archive of ocean floor data. The data existed. What was needed was someone to make sense of it. Tharp was given the job of plotting the depth profiles. It was, in the institutional hierarchy of the time, considered technical work rather than scientific work, the kind of task assigned to women while the men did the thinking. But Tharp was not simply plotting data. She was reading it. As she worked through the profiles, drawing the shape of the ocean bottom along each transect, comparing profiles from parallel crossings, building up a picture of the terrain, she began to notice something. In the middle of the Atlantic, running in a consistent north-south direction across every profile that crossed it, there was a ridge. And in the center of the ridge, there was a valley. The valley was the key. A rift valley, running along the center of an underwater mountain range in the middle of the Atlantic Ocean, implied something extraordinary, that the ocean floor was being pulled apart. That new material was rising from the Earth's interior along the ridge, pushing the existing seafloor outward in both directions. That the Atlantic Ocean was getting wider. This was, in 1952, an almost heretical conclusion. The theory of continental drift had been dismissed as geophysically impossible by the geological establishment. When Tharp brought her drawings to her supervisor, Bruce Heezen, and showed him what she had found, his response was dismissive. He called it girl talk. He told her that what she was seeing was an artifact of the data. Continental drift was impossible. Therefore, what she was seeing could not be what she thought it was. Tharp went back to her data. She checked her calculations. She extended her profiles. She looked at more data from more crossings and found the same valley in the same place with the same dimensions in every profile that covered the relevant area. It was not an artifact. It was a feature. The evidence mounted in other ways. When Tharp plotted the locations of earthquakes recorded in the Atlantic against her map of the ocean floor, they followed the Rift Valley precisely, a continuous belt of seismic activity running along the center of the mid-Atlantic ridge, exactly where you would expect it if the ridge were a zone of active geological separation. This was the evidence that moved Heezen. He changed his position on continental drift, and in 1957, the first published map of the North Atlantic Ocean floor appeared, with Heezen's name on it and Tharp's name absent. The map that Tharp and Heezen produced was not a scientific diagram. It was a work of visual art. They collaborated with an Austrian painter and cartographer named Heinrich Baran to produce a panoramic physiographic map, a visual representation of the ocean floor rendered as if seen from slightly above, combining scientific accuracy with visual accessibility. The result was breathtaking. For the first time, a general audience could see the ocean floor, could see the mountains and valleys and plains of a landscape that covered 70% of the Earth's surface and had been invisible since the planet formed. The mid-Atlantic ridge rose in the center of the map like a spine. The Rift Valley ran along its length like a wound. The map was published by the National Geographic Society in 1968. It was distributed to millions of subscribers. It is one of the most reproduced cartographic images in history. Heezen's name was on it. Tharp's was not. She was listed in some contexts as a research assistant. In others, she was not listed at all. The convention of the time, the institutional habit of attributing scientific work to the senior male figure, had erased her from her own discovery in ways that were so systematic and so unremarkable that they required no deliberate act of suppression. It was simply how things were done. When Heezen died suddenly of a heart attack in 1977, while conducting research aboard a submarine in the North Atlantic, Tharp was devastated. His death left her professionally exposed. Without Heezen as the named figure associated with the work, the institutional support for Tharp's continued research at Lamont evaporated. She was effectively pushed out. She moved her maps and her files to her home in Nyack, New York, and continued working independently. For the next 2 decades, the maps she had made continued to circulate in textbooks, in museums, in scientific publications. While she lived quietly in Nyack, largely uncelebrated, occasionally contacted by researchers who had tracked her down and wanted to understand how the maps had been made. The recognition, when it came, was genuine if belated. In 1997, The Library of Congress named her one of the 4 greatest cartographers of the 20th century. In 2001, Columbia University awarded her the Lamont Doherty Heritage Award, belatedly acknowledging the contribution that had been made in its basement offices decades earlier. She gave lectures. She was interviewed. Journalists and historians began piecing together the story of what she had done and how it had been credited. She died on August 23, 2006, in Nyack, New York. She was 86 years old. The map she made is still in use. There is a particular kind of invisibility that attaches to certain kinds of work in certain kinds of institutions. It is not the invisibility of failure. It is the invisibility of work that was done so well, and that became so foundational to what followed, that it disappeared into the landscape it had created. The map Marie Tharp made of the ocean floor did not stay a map. It became the visual foundation of a scientific revolution. The evidence it provided was the evidence that converted the geological mainstream to plate tectonics in the 1960s. The textbooks that teach plate tectonics today contain diagrams derived, ultimately, from Tharp's drawings. The understanding of the Earth that those textbooks convey rests on a foundation that she built. She built it from a desk she was not supposed to be sitting at, using data from ships she was not allowed to board, producing conclusions that her supervisor initially dismissed, and receiving credit, public, institutional, documented credit, 4 decades after the work was done. The story of Marie Tharp is sometimes told as a story about a woman who overcame the barriers of her era through persistence and talent. That framing is true but insufficient, because the barriers she faced were not incidental to her story. They were the central mechanism by which her contribution was systematically undervalued. The exclusion from the ships was also the exclusion from the institutional culture that determined how credit was allocated. The researchers who went to sea were the researchers whose names appeared on the publications. Tharp collected nothing. She analyzed everything. And in an institutional framework that valued collection over analysis, presence over contribution, the name on the grant over the mind doing the work, she was made invisible by the very structure of how science was organized. The ocean floor did not care. It was what it was: mountains and valleys, and a rift that split the planet, regardless of who drew it or whose name appeared on the drawing. The plate tectonics revolution happened because the evidence was undeniable, not because the credit was correctly distributed. But the people who find the truth, and are then written out of finding it, do not get those years back. They do not get the career trajectories they might have had. They do not get the institutional resources that flow to recognized contributors. What Marie Tharp got, eventually, was the Library of Congress and a Columbia University award, and a series of interviews in which she talked about her work with the quiet pleasure of a person who had always known what she had done and had simply been waiting for the world to catch up. She got to see her map on the walls of classrooms around the world. She got to know that the shape of the ocean floor, the shape she had revealed, from a desk in a basement, using data from ships she was not allowed to board, was now part of the permanent knowledge of the human species. That no one could take it back, that it was hers, whoever's name had been on it.